Hey everyone, welcome back to the channel. Today we're going to break down exponents and radicals, two topics that are super important in algebra, SAT prep, and beyond. So by the end of this video, you'll not only understand the rules, but also see how to use them to solve problems quickly and confidently. Okay? So please ignore the problem that you see on the screen because I want to give you some background info first. So let's start with exponents. Okay? So an exponent tells us how many times to multiply a number by itself. So for example, let's say you have 2 to the third. This is simply 2 times 2 times 2 equals 8. Okay? And the 2, in this case, is what we call the base. And the 3 is what we call the exponent. Okay? And the base does not just have to be a simple number. For example, if you have x plus 2 to the third, the entire x plus 2 would be considered the base. And this would be equal to x plus 2 times x plus 2 times x plus 2. Okay, I see a lot of people make the mistake of distributing the 3 to both terms. And they end up with x to the third plus 2 to the third, right? So that's a big no-no, all right? So be careful with that, okay? Okay, good. So let's go over some of laws of exponents with some quick examples, okay? So we have the product rule. So I'm going to just write it here. Let's say I have a base, let's call it a, to an exponent m, could be any number, right? And then I have the same base to a different exponent. Let's call it n, okay? So whenever you see this scenario, all you have to do is add up the exponents. So my end result would be m plus n, a to the m plus n. If I want a concrete example, let's say I have x to the second power multiplied by x to the third power. This would be equal to x to the fifth power, right? Okay. Let's say I have x to the third power times x to the let's use a negative one. That's x to the second, right? This is still gonna be x to the I'm gonna add up the exponents, right? So 3 plus negative 2, right? And then this is going to be 3, x to the 3. Since I have a plus and a negative and they're different signs, this ends up being a negative and then 2, right? And I end up with x to the first power, which I can just rewrite as x, okay? So again, this is the product rule, okay? Now let's take a look at the quotient rule. So now instead of multiplication, let's say I have division. So a to the m over a to the n. Instead of adding the exponents, I am going to subtract them. So this is going to evaluate to a to the m minus n. Okay? If you want a concrete example, so let's say I have y to the fifth divided by y to the second. This evaluates to y to the 5 minus 2 or y to the third power. Okay? Good. Again, that's the quotient rule. Okay, next is the power rule. So the power rule is if I have something like a to the m in parentheses, right? And outside of this, I have another exponent, let's say n. In this scenario, I'm not going to add or subtract the exponents. I am going to multiply them. So this ends up being a to the m times n, okay? So a concrete example would be, let's say I have x to the second power and all of that to the third power. My final result will be x to the sixth power, okay? Once again, that's the power rule, great. Okay, next one, the zero exponent rule. So the zero exponent rule, there's a bunch of background which I'm not going to get into, but it just says that any non-zero number to the 0 power is 1. So example, if I have 5 to the 0, that is equal to 1. 2 to the 0 power is equal to 1. Or even if I have x plus 2 to the 0 power, that is also equal to 1. Okay, assuming, this does not evaluate to 0. Okay, so again, that's the zero exponent rule. Good to memorize it. And finally, we have the negative exponent rule. So let's say I have a to a negative power n. Okay, whenever you see that, I can just rewrite that as the reciprocal, and I'll change the sign of the exponent. So it was negative, now it's going to be positive, right? Similarly, let's say I started out with, let's say, 1 over a to the negative m, right? I can rewrite this by just, again, taking the reciprocal, which in this case would be a, and I'm going to change the exponent from negative to positive, right? So this is just a to the m, okay? If I want to give you an example with actual numbers, let's say I have 2 to the negative third power, right? I can rewrite this as 1 over 2 to the third, right? And 2 to the third, is 8. So this is just 1/8, okay? Okay, great. So I think those are the main laws for exponents. Let's move on to radicals, which are basically just the opposite of an exponent. For example, the square root of 9 is 3. Why? Because 3 to the second power is equal to 9. So there's an invisible 2 here, right? So more generally, the nth root of a number is what you multiply by itself n times to get the original number, okay? And here's a key connection between exponents and radicals. So let's say I have not necessarily the square root, but any root, so let's call it n, of a number a. Ooh, that was an ugly a. Okay, I can rewrite this by using fractional exponents. So this a, even though you don't see it because it's more or less obvious, this a has an exponent of 1, right? Any number to a 1 power is just itself, right? That's why we never write the 1. But this a does have an exponent of 1. So the way to rewrite this is I'm going to rewrite the base, and I'm going to write its exponent in the numerator, okay? And the nth root in the denominator, okay? So let me color code this so you guys can see it more clearly. So I have my 1, and the root in red, okay? So let me give you a concrete example using actual numbers. So let's say I have 27 to the 2/3, okay? So if I want to rewrite this using roots, let me write the root, write the base, okay? So the numerator, this 2, is what's going to be the power of the base. So I'm going to write the 2 in here, right? And then the denominator is going to be the nth root. So in this case, we have a cubic root, the cubic root of 27 squared. Okay, so I think that's enough background info. So I think we're ready to tackle the exercises. Okay, so let's start with the first one. Okay, so we have 18x to the 4th plus 27x to the 3rd minus 36x squared. All of that divided by 9x squared. And they're saying if x is not equal to 0, which of the following is equivalent to the given expression? Okay? All right, so whenever you guys have, let me use this. Okay, whenever you guys have an addition or a subtraction in the numerator, let's say you have a plus b minus c, doesn't really matter. All of that divided by d, divided by just one term, I can break that up in this way. So this is going to be equal to a over d plus b over d minus c over d, okay? And we're going to do something very similar here. So I'm going to break up that big numerator into 3 separate fractions. Namely, I'm going to end up with 18x to the 4th divided by 9x to the 2nd plus 27x cubed divided by 9x squared minus 36x squared divided by 9x squared. Okay? Okay, great. Okay, let's tackle it one term at a time. So, I have 18 divided by 9, okay, which is 2. I'm just going to, you just divide the coefficients like a regular division. So 18 divided by 9 is 2. And now we're going to apply the exponent laws that I taught you earlier to the second part, the part with the x's. So we have x to the 4th divided by x to the 2nd, right? So if you remember the quotient rule, it says when I have the same base, right, and on the numerator and the denominator, I'm going to subtract the exponents. So I'm going to write the same base, x, and I'm going to subtract the exponents, namely 4 minus 2. And that means I end up with 2x squared, right? So that means I can already eliminate well, actually, let's not get ahead of ourselves. Let's go on to the next one. Okay, so now I have 27x cubed divided by 9x squared. Again, I'm going to divide the coefficients. So 27 divided by 9 is 3, okay? And now I have x cubed divided by x squared. Again, you have another division. So I'm going to apply the quotient rule. And this ends up being just the same base. And for the exponents, I'm just going to subtract them. So 3 minus 2 is equal to 1, which I don't really need to write down, right? Okay, and finally we have 36x squared divided by 9x squared. I'm going to divide the coefficients. So 36 divided by 9 is equal to 4. And then I have x squared divided by x squared. So I can do this both ways, but hear me out. So let's say we apply the quotient rule. Again, I'm going to write down the same base, and I'm going to subtract the exponents. So 2 minus 2 equals 0, right? And if you remember the 0 exponent rule, it says that any non-zero number to the 0 power is 1. And they told us that x is not equal to 0. So that means that this term here, x to the 0 power, is just equal to 1, right? And anything multiplied by 1 is just itself. So I can really pretty much ignore this x to the 0 power, right? And that means I'm left with 2x squared plus 3x minus 4, or A as our final answer, okay? All right, let's move on to the next one. All right, so now we have x to the 5r divided by x to the 3r minus 2s equals x to the t, okay? Please note that the exponent in the denominator on the left side is the entire 3r minus 2s, okay? So they're saying if r plus s is equal to 6 and x is not equal to 0, what is the value of t in the equations shown? Okay, so let's do a little manipulation. Let's do a little manipulation on the left and see what we get. Okay, so I have x to the 5r divided by x to the 3r minus 2s. So I have the same base in the numerator and the denominator, so I can go ahead and apply the quotient rule, okay? Which means I can rewrite the base, x, and what's going to be my final exponent is going to be the subtraction of my exponent in the numerator and the denominator. So again, I'm going to write 5r minus, and I'm going to subtract the denominator's exponent. So that is going to be 3r minus 2s, okay? I put it in parentheses because there's two terms here, Okay, so I have to be careful there. Okay, so again, I'm going to rewrite the base, 5r again. And whenever you have a negative in front of a parentheses, right, that means I'm going to distribute that negative to every single term in the parentheses. But in very simple terms, that just means I'm going to rewrite everything that's inside the parentheses, but with the opposite sign. So if it was positive, I'll write it as negative. If it was negative, I'll write it as positive. The 3r was positive inside the parentheses, so I'm going to rewrite it as negative 3r, right? And the 2s was negative inside the parentheses, so I'll rewrite it as plus 2s. Okay? All right, great. So next step, I can subtract the 5r with the 3r because, you know, they have the same r, right? The same variable. So I just subtract the coefficients. So 5 minus 3 equals 2. So now I'm left with 2r plus 2s. Okay? And just don't forget that all of this is in the end equal to x to the t, right? I haven't forgotten about that. Okay, so let's see what else we can do. You have a 2 right here and a 2 right here. So if you remember my first, I believe the first or second video, I used something called common factor. So we're going to have to use it again here. Okay, since the 2 is the common factor, I'm going to rewrite this as 2, or the common factor, open parentheses, and I'm going to divide each term by the common factor. So if you recall, the way this is done is, let's say you have 2r, right? It's our first term. That divided by 2, right? That just means I'm going to divide the coefficients. 2 divided by 2 is just equal to 1, so this ends up just being r. And similarly, I have 2s divided by 2, and this ends up just being s, okay? Okay, great. Now I have x to the second power times r plus s. And if you reread the problem, it says r plus s is equal to 6. So I can go ahead and substitute that. So I end up with 2 times 6, right, is equal to x to the t, right? And if I evaluate that, that means I have x to the 12th power is equal to x to the t, okay? And if you just compare the left and the right side, I can deduce that t is equal to 12. And that means that our answer is B, okay? Great. Let's. All right. So our third problem says if a and b are positive integer constants and x to the a times y to the b is equal to negative 128, where x is less than 0 and y is less than 0, which of the following must be true? Okay. So that means whatever option we pick has to be true in every case, okay? So be careful with that. So I have a negative number, okay? I have two negative numbers, right? Both x and y are negative. If you recall, if you have, let's say, a negative 2 times a negative 2, that equals positive 4. If you have positive 2 times positive 2, that equals positive 4 as well, right? So if you're multiplying two numbers that have the same sign, you're going to get a positive outcome, right? If they're different, let's say one of them is negative and the other one is positive, you'll end up with negative 4. Likewise, if the first one is positive and the second one is negative, you'll also end up with negative 4, okay? So, since my answer is negative 128, right? That means that I have to go down this road, right? Where one of my terms needs to end up negative and the other one of my terms needs to end up positive, right? Okay? Even though both x and y start out negative. But there is an additional, I don't know if you can call it a rule, but there's a little trick here that says if you have a negative number, let's say negative, let's use -2 again. Okay, so -2 to the second power is equal to -2 times -2, and that means I end up with a positive value, right? But now let's say I have -2 to the third power, right? That's going to be equal to -2 times -2 times -2, okay? So we know that -2 times -2 is going to be equal to +4, right? So let's rewrite this. And now I have a positive number multiplied by a negative number. And if you remember, if you have two numbers multiplying that are of different signs, one is positive and one is negative, you'll end up with a negative value, right? Okay? So if I were to do -2 to the fourth, that's going to end up being -2 times -2 times -2 times -2, right? This is equal to +4, and this is equal to +4. Again, I have two numbers multiplied that have the same sign. If they have the same sign, my end result will be positive, right? Okay, so you kind of see a pattern here. And the pattern is, if the exponent is an even number, okay, if you have a negative number, a negative base to an even exponent, your end result will be positive. If you have a negative base to an odd exponent, like this here, your end result will be negative, okay? So that means, let's just erase this. So this means that since I have two negative numbers, right? I have x is negative and y is also negative. I need one of these a or b to be odd, right? And the other one to be even, right? Because a negative number to an odd exponent will give me a negative, right? And a negative base to an even exponent will give me a positive, right? And then when you multiply two numbers that have different signs, your end result will be negative, okay? But it doesn't necessarily mean that the a has to be odd. You can have a be even, right? As long as the b is odd, right? In this case, you would end up with the first term being positive and the second term being negative. But your end result will also be a negative number, right? So a can be even, right? Like in the second case, but it doesn't have to be, right? So a is not the right answer. Likewise, b is not the right answer because of the same reason. Now we're between c and d, right? So they're saying I need to multiply these exponents, a times b, and I need to say whether that result is always going to be odd or always going to be even. Okay? So whenever I have an odd number multiplied by an even number, that result will always be even, right? So you can just plug in some numbers if you're unsure of this, right? Let's say a is odd. So let's say a is 3 and b is even. So let's say 2. 3 times 2 equals 6, which is an even number, okay? And you could give it many more, you can substitute it for different values until you feel comfortable, but it's a rule. Whenever you have an odd number multiplied by an even number, your result will be even. So that means that our answer for this exercise is D. A times B must be even, okay? All right, let's move on to the next one. All right, so now I have which of the following expressions is equivalent to negative x to the 1/4 power? okay? So let's not worry about the negative for now, right? Because it's outside of the x and the 1/4, right? So the x to the 1/4, if you recall, there's a way to rewrite this using a root, right? And the way you do it is you write the root, write the base, okay? The numerator is the exponent of that base, okay? So again, you have x to the first power, okay? And then the denominator is going to be the nth root, okay? So x to the 1/4 is just the 4th root of x, right? And I don't need the 1 because, you know, like we said, it was pretty obvious. So x to the 1/4 is equal to this guy right here, okay? And now I can just reintroduce the negative, okay? The negative 4th root of x, okay? So that is our answer here. If this exercise would have been what is the equivalent to x to the minus 1/4, if the minus sign were inside the exponent, then we'd end up with something different, right? We'd end up with this being 1 over x to the 1/4, right? And then I can just rewrite that x to the 1/4 like we did below to rewrite it as 1 over the 4th root of x, okay? So the placement of the negative sign is very important, okay? Very, very important indeed. In this case, since it was outside of everything, the entire term will be negative. Okay, if it would have been inside with the exponent, you end up with actually a positive value. Okay, so to summarize, our answer is C. Okay, great. Moving on. All right, so now we have 8 plus the square root of 2x plus 29, all of that divided by 3, and that equals 9, okay? And I know it's a square root because unless they tell you otherwise, if you don't see a number here, right, you're always going to assume square root, okay? All right, so for what expression of x is this equation true? So let's isolate x. So if you recall the first few videos, to isolate a variable, I'm going to start getting rid of whatever's farthest away from it. In this case, I'll start with the 8, okay? So the 8 is adding, right? It's a positive 8. So I'm going to subtract 8 on both sides, okay? So I'm going to subtract 8 on the left, but whatever I have to do on one side, I have to do it on the other one. So that means I have 9 minus 8 on the other side. And this gives me the square root of 2x plus 29, all of that divided by 3, and that equals 9 minus 8 equals 1. Okay, great. So now I'm going to get rid of the next farthest thing from the x. In this case, the 3, that's dividing, right? So I'm going to apply the opposite operation, which is multiplication. So I'm going to multiply by 3 on both sides, right? So on the left side, I can cancel out the 3 with the 3 because that's 3 divided by 3, which equals 1. And I'm left with the square root of 2x plus 29 equals 1 times 3 equals 3. Okay, great. Now we're going to get rid of the square root. So I'm going to apply the opposite of square root, which is squaring, right? I'm going to square both sides, okay? And that will get rid of this square root on the left, right? And that means I'm left with 2x plus 29 is equal to 3 squared. 3 squared we know is 9, okay? So we'll write it as 9. Okay, great. Now what's the next farthest thing from the x? Now we need to get rid of the 29. The 29 is adding, So we'll apply the opposite operation, which means we're going to subtract 29 on both sides, okay? So these cancel out, and I'm left with 2x equals 9 minus 29. They are different signs, right? The 9 is positive, the 29 is negative. So I will subtract the values. So 29 minus 9 is 20, right? And the sign will be that of the greater value, right? So the 29 has a greater value than 9, right? 29 is larger than 9. So the end result will be negative, okay? Great. So now I'm just left with the 2x. I have to get rid of the 2. The 2 is multiplying the x. So I will divide by 2 on both sides, okay? And that leaves me with x is equal to negative 20 divided by 2 is 10. So x is equal to negative 10. And that means our answer is A. Okay? All right, moving on to the next one. All right, this is our last one. So we actually have a system of equations. It's a little different from the previous video. The previous video dealt with linear equations. This case, we have one linear equation, but the other one isn't. So let's see how we can tackle this. So they give you the two equations and they say if z is greater than 0, what is the value of z? So we need to isolate z. But there's some extra steps that we need to take into account. Okay, let me rewrite this. 3z squared minus 11 plus 2x equals 22, right? Okay, so I'm going to get rid of the 2x on the left by applying the opposite operation, which means I'm going to subtract 2x on both sides, okay? That means I can cancel these out, and I'm left with 3z to the second power minus 11 equals 22 minus 2x, okay? So I have two variables. I have a z and an x, but they're only asking about z. So I need to find the value of that x, right? So I'm only left with one variable, z. But luckily, I have the other equation to help me out. I have 3x is equal to x plus 14, right? So I can isolate the x term from this first equation and substitute it in the second equation, okay? So if I subtract x on both sides, right? So I can bring all the x terms to the left. That means I'm left with 3x minus x. I subtract the coefficients, so that's 3 minus 1 is 2. That leaves me with 2x on the left equals, the x's on the right cancel out, and I'm left with 14. So I know that 2x equals 14. And just as a coincidence, I actually have 2x in the second equation, right? So I don't even need to isolate further. I can just substitute the 14, right? So putting it all together means I'm left with 3z to the second power minus 11 equals 22 minus 2x, which is 14, okay? Great. And 22 minus 14 is equal to 8, okay? So I have 8 here. Great. And just like the previous exercise, I want to get rid of the square root. So I'm going to square both sides. Okay. That gets rid of the square root on the left. And I have 3z squared minus 11 equals 8 squared, which is 8 times 8, which is 64, right? Okay, great. So now I have the 11. The 11 is subtracting, right? So to get rid of it, on the left, I will apply the opposite, which is addition. So plus 11, right? That gets rid of that on the left, and I'm left with 3z squared is equal to, that is 64 plus 11 is 75, okay? Great. So now I have the 3. So the 3 is multiplying. So I'm going to apply the opposite operation, which means I am going to divide by 3 on both sides. Okay. 3 divided by 3 is just 1. So I can cancel that out, right? And 75 divided by 3 is 25. So I'm left with z squared equals 25, right? But they are asking for the value of z, not z squared. So I'm going to apply the opposite of squaring, which is square root. So I'll apply square root on the left and on the right, okay? That will get rid of the square term on the left, which means I'm left with z equals the square root of 25, right? So the square root of 25 is which number multiplied by itself gives me 25, which is 5, right? So z is equal to 5, and that means our answer here is C, right? 5. Okay, so I hope this video was useful. If it was, please subscribe, please give it a like, please share with your friends. If you need some extra help, whether it be for the SAT, a math exam, or just, any math exam that's coming up, just please check out my website, tutoringbyalejandro.net, for either one-on-one or group online tutoring. So thanks again, everyone, and I'll see you in the next video. Okay, bye-bye.